Hello, I am Abhiramas. In today's presentation, we are going to know about functions and object oriented programming in CPP. So, moving on, we have introduction. So, functions, they are reusable blocks of code for performing specific tasks. They helps in organizing code and making it more manageable. So, functions are reusable blocks to perform a specific task, or they are a set of instructions. So, what is OOPS, or Object Oriented Programming System? Object Oriented Programming is a technique which involves the real world entities such as objects, classes, inheritance, polymorphism, etc. So, let us look deeper. So, moving on to functions. Functions is a fundamental concept that plays a crucial role in structuring and organizing code. So we know that a function is a basic building block of a program. There are a set of instructions for performing tasks. So they take in arguments, process them, and return a value. We have different types of functions. So let us look into the general syntax. It includes a declaration and definition. So function declaration, it is also known as function prototype. So the syntax is return type, the function name, and the parameters in parentheses. So then function definition. A function definition, it includes the actual body of the function. That means it actually contains the code of the function to be executed to perform a specific task. So the syntax is return type, function name, and the parameters in parentheses, and the function body. That means the function body, it is enclosed within curly braces. We are writing the code to be executed. So then what are parameters? So parameters are values passed to a function when it is called, or they allow functions to receive input, process it, and return a result. Parameters are variables. They are listed as part of the function's definition. So they actually act as placeholders for storing the values. So some key points of parameters include declaration, initialization, and usage. So parameters are declared inside the function's signature, and when a function is called, the arguments are assigned to the corresponding parameters, and the parameters are used like regular variables. Different return types in functions in CPP. We have void, int, double, etc. So void, it indicates that the function does not return a value. It returns nothing. Then int indicates that the function should return an integer value. For double, indicates the function should return a double precision floating point value. Char indicates that the function returns a character value. Then string indicates that the function returns a string. So we are going into an example of a function. Here we have the header file IO stream, then the function declaration. The name of the function is add with two parameters a and b of return type integer. Moving on to the main function, we have assigned the function code, that is add 53, into a variable result. Then we have print the value. After that, the function definition is there with the return type, name of the function, and parameters a and b. So we are going to look at different types of functions. We can broadly categorize the function into two main types, that is built-in functions and user-defined functions. Built-in functions. Built-in functions, they are also known as library functions. They are provided by the CPP program that is actually developed during the time of developing the programming language. And user-defined functions, they are used, or they are created by the programmer or the user for performing the specific task as per our requirement. The functions helps in organizing code. It makes it reusable and it improves the readability. So what is the importance of functions for code modularity? So we are highlighting some key points such as separation of concerns, reusability, readability and maintainability, and testing and debugging. Separation of concerns. Function allows us to break down a large program into simpler one using blocks of codes. Then reusability. The main advantage of the function is code reusability. We can use the code as many times we require based on our need. Then readability and maintainability. The functions enhance the readability of the code by organizing it into logical sections. Then testing and debugging. Functions are developed and tested independently, so we can ensure that each part of the program works correctly before integrating them into the whole function. So next we can move to OOPS, or Object Oriented Programming System in CPP. So Object Oriented Programming is a type of technique that organizes the software design around objects and their interactions. The main aim is to implement real-world entities like inheritance, polymorphism, abstraction, encapsulation, etc. So this approach helps in organizing code. It makes it more modular, reusable, and maintainable. So we are going to the key concepts of object-oriented programming system. First one is class. It is actually a blueprint or template that defines the properties and behavior of an object. So it defines a data type by bundling data and methods that operate on the data. They are one of the fundamental concepts in OOP, as they provide a structured way to organize and manage the code. Then objects. Object is an identifiable entity with some characteristics and behavior. So actually, when a class is defined, no memory is allocated. But when the object is created, memory is allocated. So each object contains data and code to manipulate data. So class is a blueprint that defines the properties and behavior of an object, while object is an instance of a class with its own set of attributes or data and functions. So next we have an example of a class. So we have the header file iostream.h. The name of the class is car. So inside the body of the class we have public variables brand, model and year with a public function display info. In the main function we have created an object car1 and car2. So here the objects are created from the car class. The attributes of each object are initialized with specific values, and the display info function is called on each object to print its details. So the next concept, or the next major concept in OOPS, is abstraction. So what is abstraction? Abstraction is the process of exposing only the necessary information to the outside world while hiding the internal details. It is one of the fundamental concepts in OOPS. It focuses on hiding the complex implementation, as we know. So it actually simplifies the interaction with objects, making the program more effective. So there are two types or two ways which we can enforce abstraction in programming. That is abstraction using classes and abstraction using header files. So using classes, we can implement abstraction. It helps us to group the data and member functions using available access specifiers. We have access specifiers such as public, protected, and private. Then in header files, for example, we can consider the power function, which is included in the math.h header file. Actually, there are a lot of code behind the function for its perfect execution, but we are just calling the power function present inside the header file math.h, and without knowing the underlying algorithm according to which the function is actually calculating the power of numbers. So we can look some key points in abstraction. The abstraction leads to simplification, hiding implementation details, and it actually focuses on what is necessary. So the next major term is encapsulation. Encapsulation is a fundamental concept. It's another fundamental concept. It is a process of bundling data and methods that operate on that data within a single unit called a class or object. Actually, it helps to protect data from external interference. It improves code organization and reduces coupling. This protects the data and methods from outer inference, as we know. And the key points are data hiding, it improves security, and it simplifies interaction. So we have an example of abstraction and encapsulation. So here in this example, we can see a class simple bank account. We have private variable balance, public variables, public functions, etc. So actually here the balance attribute is private, which means it is hidden from the outside world, or encapsulation. The deposit function and get balance function methods or get balance functions are public, which means that they can be accessed from outside the class, or abstraction. The deposit function modifies the private balance attribute, but the user of the class does not need to know how the balance is updated. The getBalance function provides a way to access the private balance attribute without exposing its implementation details. So that's all about the example. Next, we have concepts such as polymorphism and inheritance. We are just defining those concepts. Polymorphism is a concept in object-oriented programming. It is actually allowing objects of different class to be treated as objects of a common superclass. That means, or it's the ability to take more than one form. Then inheritance is another fundamental concept. It allows a class to inherit the properties and features of another class or from an existing class. So we can look some benefits of object-oriented programming. The first one is modularity. That is, the code is organized into classes, so it makes us the program user-friendly and efficient. Then reusability. So classes can be reused across different programs as per our requirement. And scalability. It means that new features can be added with minimal changes to existing code. That means we can add new features without any suffering or without any struggle. Then maintainability. The code is easier to maintain and debug due to its modular nature. So OOP in CPP provide a clear structure for programs, making it a popular one. So that's all about the topics. We can move to the conclusion. So understanding functions and object-oriented programming is essential for mastering the CPP and developing efficient, modular, and maintainable software. So by applying the principles, there are a lot of principles such as encapsulation, inheritance, polymorphism, abstraction, etc. that stimulates the real-world scenarios. Then the use of functions enabled us to modularize our code. The main advantage of the function is the code reusability, and it improves readability. So these concepts from foundation of CPP programming are crucial for building complex and efficient applications. Thank you.